Welcome back to the London Futurists podcast. Our guest in this episode is Sterling Anderson, a pioneer of self-driving vehicles. With a master's degree and a PhD from MIT, Sterling led the development and launch of the Tesla Model X, and then led the team that delivered Tesla Autopilot. In 2017, he co-founded Aurora, along with Chris Urmson, who was a founder and CTO of Google's self-driving car project, which is now Waymo, and also Drew Bagnell, who co-founded and led Uber's self-driving team. Aurora is concentrating on automating long-distance trucks and expects to be the first company to deploy fully self-driving trucks in the US when it deploys big driverless trucks, 16 tons and more, between Dallas and Houston by the end of this year. Self-driving vehicles will be one of the most significant technologies of this decade, and we're delighted that one of the stars of the sector, Sterling, is joining us today to share his perspectives. Sterling, welcome to the London Futurist podcast.
Thanks, Cal.
It's a pleasure to meet you, Sterling.
Likewise.
So, Sterling, let's start with your immediate plans for Aurora. You plan to deploy, as I said, fully self-driving trucks in Texas this year. To the extent that you can tell us, how many will there be and where will they travel? And how significant a milestone in the development of self-driving vehicles do you think this will be?
We have 36 trucks operating commercially in Texas. We've been operating commercially at smaller scales for a couple of years there. These trucks are pulling real loads for real customers. We drive on 2 routes, one between Dallas and Houston, one between Fort Worth and El Paso. These trucks today are supervised by onboard humans who are there as we finalize the validation of the self-driving system. But the self-driving system is in control and operating these trucks. These supervisors are there to oversee the system, to annotate, effectively take notes on what it's doing, what it's not doing, and provide a backup should it make the wrong decision. These humans we expect to remove here in the next little bit. And when we do, we call that commercial launch, where effectively we'll have trucks without onboard human supervisors operating on these lanes. So it's an exciting time for that. We've got a number of partners and customers that we're working with, whose loads we're pulling, whose trucks our system is driving, and whose hardware ultimately we'll be using.
For people who are not so familiar with the geography of Texas, and some of our listeners may only have a vague idea, and how long are these journeys and how much time is involved?
It's a good question. Dallas-Houston is about a 200-mile journey. It's about 3.5 hours. It is a relatively shorter segment. Fort Worth, El Paso is an upwards of 10-hour journey, east-west across the state from Dallas, Fort Worth area over to El Paso in the west of the state.
And why are you starting with trucks rather than, say, robo-taxis like Waymo?
Yeah, it's a good question. We can talk through commercial, technical, and other reasons. The first on the commercial side is the most compelling. Specifically, trucking is a $1 trillion business in the United States today. It's a business that is structurally hamstrung by human drivers who can only drive 11 hours at a stretch and then have to sleep. These human drivers also have to eat. They have to take breaks along the way. And as a result, the movement of goods, 70% of which in the United States move by truck, is hampered by a relatively slow pace. It's limited by what humans can do. A self-driving truck eliminates that human element, not just the drowsiness, not just the need to sleep, not just opening up the operating hours, but also dramatically improving the safety of our roadways. In a world where 500,000 crashes or so happen each year on heavy trucks, leading to thousands of deaths, self-driving systems that are much safer, that are much more performant, can both improve the safety of the roadways, but also dramatically improve the businesses of all those who rely on trucks, which is a very large chunk of the U.S. economy. Today, the trucking industry operates at about an 80,000 truck driver shortage, and that's expected to double in the next few years. As you might imagine, these are dull, dangerous jobs. They require humans to be on the road for sometimes upwards of days to weeks. This is just not a appealing place for a human to take a job, which is frankly part of what's behind the deficit in drivers that we have today. So opportunity is immense, just given size of market, given significance of opportunity and value that can be created in a self-driving trucking world. Now, robotaxi, as it's sometimes referred to, or self-driving vehicles operating in a ride-hailing capacity, is also compelling, but more from a safety standpoint and a experience of rider than it is from a commercial standpoint, given the fact that today, taxi economy workers are relatively plentiful. The cost offset is relatively lower, and the opportunity in terms of things like hours of service is a little bit less because typically you can bring on and offline these drivers at will.
And given that there's 80,000 drivers too few in America, at this point, presumably you're not getting any pushback from unions to say, hey, you're going to destroy jobs.
I think there's always that pushback. Ludditism is alive and well in many sectors. I think we see it everywhere where technology disrupts or adds value that humans just weren't well suited for. I imagine, though I don't know, that automation of many other tasks that were dangerous and problematic were met with similar pushback. I think in the trucking sector, the long haul routes for which autonomous trucks are most opportune, given some of these benefits that I just mentioned, these are the least appealing to human drivers. Some of the more appealing jobs are those that allow them to sleep in their own bed every night. It's regional jobs, far more interesting, far less demanding, far less taxing, frankly, on the human body and just on the lived experience that they've got. From that regard, we think that we're in a better position than we might otherwise be, given the fact that these trucks are taking on routes that are not appealing to humans, where the deficit is felt most acutely. But we do appreciate that there will, I expect for quite some time, be some reticence to accept something that feels like it's going to be doing a job that a human could otherwise do.
Yeah. And what is unique about Aurora? Why did you start it? You and Chris and Drew were leading the most important self-driving projects in the world at the time.
Mm-hmm.
So why did you come together to start Aurora?
Yeah, we were at Tesla, Google, and Uber at the time. We saw a unique opportunity to create an independent company that could enable entire industries. What I mean by that is rather than one that was limited by the respective goals and constraints or limitations of the companies we were at, by creating an independent self-driving company, we could partner with a number of OEMs to build the platforms. We could partner with a number of carriers and ride-hailing companies. We could partner with a number of suppliers. We could partner with operating partners. And effectively, with the considerable expertise that we developed, each of the three of us and all the people that we brought on board, create a compelling product that could move quicker when unconstrained by the limitations that Tesla had, that Google had, or that Uber had. And this is borne out, I think, in significant ways. As it relates to the partnerships that we've struck, we found remarkable appetite from many of the leading companies in the space. Today, 2 of the top 3 heavy truck manufacturers are partnered with Aurora, building trucks specifically suited to the needs of the self-driving system that Aurora has built. We have some of the biggest trucking companies in the world, between FedEx and Werner and Schneider and Uber Freight and a few others, who are all working with us in pilots, commercial pilots, in preparation for them purchasing the trucks directly from these OEMs and operating them in their respective businesses, to Continental, one of the world's leading tier 1 automotive suppliers, who's working with us to build the self-driving system, specifically the computer and the sensors that go into these trucks to be ultimately installed line-side in the assembly facilities of these heavy truck manufacturers. So we've seen that thesis of an independent play can enable an industry bear out in remarkable ways to date, and we're just getting started in terms of volume.
You said that your setup might allow you to move more quickly, but it's still been a long haul.
It has been.
2017, I think you were founded. Both Callum and I, with our futurist hats on, in the years before then, were anticipating that these vehicles would be on our roads more quickly. What's your perspective now about how long it takes for such a big project to actually come to fruition?
you weren't the only ones who were overestimating technology's impact in the short term and potentially underestimating it in the long. I think it's a common dynamic. But one of the unique elements here is just how large the world is. And by large, I mean combinatorially complex as it relates to the number and variety of scenarios that can play themselves out on the world's roadways, particularly when those roadways are shared with somewhat unpredictable humans. It's just a very, very long tail of edge and corner cases that have to be addressed by a self-driving system. One of the things that gives me more confidence today than I've ever had in 15 plus years of developing in this space is the approach that we've taken, enabled by recent advances in artificial intelligence, specifically in foundation models and a number of other developments that have happened over the last several years. 15 years ago, when I started doing this, we were largely procedural in nature when we wrote code. So this was everything from optical flow to structure for motion to a number of other classical techniques, even on the perception side, to understand the world around you. And then certainly a number of procedural techniques as it relates to motion planning and decision making for that vehicle. In the last several years, we've seen a number of advances that, frankly, one of which we were able to use as a founding premise for Aurora. So when we started the company in 2017, we wrote an article. It's still somewhere, I assume, on the Aurora's blog if you want to read it, where we talked about the need for much heavier machine learning in self-driving than had ever been done to that date. And as a result of this recognition, we pioneered a few things developmentally. First, a developmental regime that used far more heavily virtual testing than it did on-road empirical testing. And the reason that was valuable is it allowed us to expose the system to a much larger corpus of data and scenarios that it could encounter on the road that even a very large fleet is unlikely to encounter without substantial driving. The second is it allowed us much more rapid turnaround and much faster iteration cycles on our development. The third is it enabled effectively the generation of far more data with which to train what was effectively a learned system rather than the more procedurally encoded one. And that third bit led to what we call verifiable AI, which is effectively a set of AI modules working in concert together with a set of interstitial invariants. Think of these as software control rods placed strategically throughout the code that ensure that none of these modules will come up with something that just is fundamentally out of touch with reality. You don't want your perception system silently failing to detect something or detecting something that is anomalous and you not know about it, and it find its way into downstream networks that are making decisions around the motion planning or the controls for that vehicle. And so that verifiable AI has been a unique element of Aurora's technology stack that frankly allows us much more credible safety guarantees for the system because we've got it. But because it's also learned in each of these modules for each of these respective systems, it will adapt and result in emergent behavior in different scenarios that you just wouldn't otherwise get with more procedural code. The final thing is, as I mentioned, we've certainly innovated on the partnership side. I think we've built a partnership ecosystem that is unrivaled in the autonomy space, supported by many of the biggest companies in the world, between the manufacturers and suppliers and carriers. What we've also done is innovated on the hardware front. So as it relates to trucks, listening to that spiel on the commercial opportunity of trucks, you might ask, why isn't everybody doing this? 80,000 truck drivers short, doubling soon, opportunity to drive these trucks 24 hours a day instead of 11. Why wouldn't this be more common? Well, one of the key technological reasons is when we started Aurora, no one could see far enough. Traditional time-of-flight LiDAR, which is really important for a credible perception system that doesn't fail in unpredictable ways, is limited by eye safety requirements and a combination of its susceptibility to background sources of radiation, be that the sun, xenon headlights, other lasers, to see on the order of 200, 250 meters, depending on the reflectivity of the object and the environmental circumstances in which it's operating. That's not enough for a truck. In fact, California classifies 200 meters as limited visibility. It's like driving into a dense fog. You'd be crazy to do that with your passenger vehicle at 75 miles an hour, much more so an 80,000-pound truck driving into a dense fog at 75 miles an hour. One of the things we had to do is overcome that. And in the early years of Aurora, we found a company called Blackmore, based out of Bozeman, Montana, who'd been developing for 15 years with the Department of Defense a frequency modulated continuous wave LiDAR technology, which, much like FM versus AM signal modulation that you would use for radio or any a variety of other bandwidths or signaling techniques, once we bought this company, Blackmore, we developed what we call first light. This is the laser that sees over twice as far as a traditional time-of-flight LiDAR. It sees instantaneous Doppler off of objects, which, as you might imagine, is a significant thing when you're operating on the freeway. You see something very far away, and you want to know, was that a rock or is that a vehicle? And when you've got Doppler, you know how fast it's moving, and you can infer what it likely is. That ability to see at much longer ranges was a unique enabler and unlock for us. In fact, it occasioned our public disclosure of our trucking ambitions once we developed that, at which point it became a technically feasible problem for us to solve. So that's a long answer to a short question.
That's very interesting. The company that you were at before, Tesla, famously doesn't use LiDAR because Musk took the view that LiDAR was never going to be cheap enough to make the system scalable commercially. And maybe this only applies to cars and not to trucks. But you've obviously changed your mind about LiDAR. Is that because you've moved to trucks and away from cars? Or do you think actually LiDAR is going to be essential in cars in the way that Waymo appears to at the moment?
We expect to deploy in cars as well, but that's not our first product. Our first product is in trucks. That allows us to build a large scale business, which itself brings down the cost of the bill of materials, including of the LiDAR, that allows us to enter ride-hailing profitably as well. So no, you can operate a profitable ride-hailing operation with a self-driving system with LiDAR that are cost compatible with that application. But you need large scale. You need, obviously, a production operation for those LiDAR that's not bespoke and handmade, which is the case for many prototype systems today. And all of these things we're working on, as I mentioned, with this Continental partnership. As we build our self-driving system at very large quantities for trucks, we've actually architected it so it's that same hardware that goes onto our passenger vehicles as well, where we're partnered with Toyota and with Uber to deploy robotaxis. That will leverage the cost curve. It will leverage the economies of scale. It will leverage the opportunities that we've created with our trucking business to operate ride-hailing vehicles profitably. Now, to your broader question, though, of why has this been eschewed by others? It is really cost. But I think I mentioned at the top of this call is that various companies operate with various constraints. And when you're an automaker, you operate under the constraint of needing to sell vehicles. If you don't sell vehicles, you die. And when you've got to sell vehicles and you don't yet have a system that fully works, you can't sell it on the promise of a system that will work and therefore price in the incrementally higher initial cost of the hardware. You have to sell it at a price that customers are willing to pay. And that typically doesn't include enough for covering the cost of a LiDAR system early on. So there are certain constraints that an automaker operates under that we don't. The reason for this is we will be deploying our vehicles in fleet settings. Certainly in trucks, that's how they operate today anyway. In robotaxi as well, having an owner-operator that is not a individual customer who is sensitive to a few $1,000s for extra equipment on that vehicle is a big deal, because that operating partner who's capitalizing and managing that fleet can make up their investment relatively quickly given the returns on those assets. So ownership model matters as it relates to the constraints around cost.
If you now want to look at different routes, you've been testing on a couple of routes. If there's a different long distance route, is that going to take a lot of retraining?
We expect not. And the reason for that is twofold. First, as I mentioned, this verifiable AI approach is designed specifically to adapt to and respond to scenarios it's never seen before. We've seen many examples of this. On the road today, as our trucks operate, while the corpus of tests against which the system is developed in our virtual environment is extremely large, it's not complete in terms of its coverage of every possible thing that could happen every possible place. As you might imagine, that's an unbounded set that just wouldn't be feasible. but we often see our trucks operating on road, seeing something that's not actually in the test set against which they were developed, behaving in emergent ways that are right, that adhere to the rules of the road, these invariants that we've placed interstitially throughout the code, but also manifest very human-like behaviors in response to other actors, in response to the scenarios that they encounter. So that's one on the technological preparation side of the truck. The other side of this, as it relates to the way that we're starting, is trucking operates a more homogeneous network of roadways generally than does ride hailing. Rather than driving the inner city streets that a ride hailing vehicle would be expected to drive, trucks, for the most part, particularly on these long haul routes, stick to highways, on ramps, off ramps, arterial roads, industrial urban settings. They get into some intersections, traffic lights, things like that, but it's typically at the outskirts of cities and in places that are very, very common. It looks very similar in Texas to the way it looks in Arizona, to the way it looks in other regions of the country. And that homogeneity or that self-similarity in the U.S. highway network is something of a boon for self-driving trucks who deploy on it, just because any new route that they take on is going to look a lot like the last routes that they operated. So a couple of specific examples. We started operating Dallas-Houston, as I mentioned, about 200-mile route, developed against the roadway conditions and scenarios that we expected to encounter there, and then deployed trucks to Fort Worth, El Paso, 3 times as long, and initially run this as a trial to see what's different, what is an encounter that it's never encountered before. And we found effectively 2 things. First, it took more inclines, declines, so it needed to use engine braking, which was a capability we hadn't yet developed at that point, but that was relatively quick, as you might imagine. And it encountered an inland border crossing, which is effectively a toll booth type passage at which these trucks are checked, for which we partnered with the department who oversees these to manage passage without a human aboard. And that was it. Everything else were driving capabilities, roadway scenarios that these trucks had already encountered and were driving every day between Dallas and Houston.
You say that forecasters often overestimate the pace of change in the short term, but underestimate the longer term impacts. So what do you think the longer term impacts will be? And are these 10 years in the future, 20 years in the future, or how far?
Well, if I said that today, I'd probably be overestimating. But all jokes aside, I think the opportunity, particularly for self-driving trucks, we expect this to scale fairly rapidly once we've unlocked that unsupervised operation on the road. As we do, just because of the similarity of the road network, we expect ultimately, whereby ultimately I mean in the next couple of years alone, to be constrained not by technical factors, but by operational ones. Really, the limit will be the speed at which we can roll out the operations to support these trucks, be that the service and maintenance networks that are required, be that the production of these trucks. But a big part of the reason that we've partnered as we have with leading players in the ecosystem is to alleviate those constraints. No one is better suited to pump out these trucks at very large scales and very high reliability and even support them downstream than the OEMs who designed them. No one is better suited to do the same for the self-driving hardware than one of the leading suppliers in the world who does that every day for the parts that they supply in the automotive world. And no one is better suited to operate these trucks in service of their customers than the shippers, the carriers, the private fleets who are operating today in the world. We've looked to ameliorate some of the constraints that might otherwise be operable here. Certainly we'll play our part in this, in enabling and connecting and facilitating this ecosystem. But I think the growth and, as you asked, the long-run implications of self-driving trucks on our roadway, I expect to ultimately be far safer roadways. I expect to be much more efficient supply chains. I expect to be far less brittle supply chains, less brittle in as much as they are far less dependent on a human workforce that is both heavily constrained, operating short of what the industry needs, and subject to disruptions from any number of directions.
Those impacts on transportation are, I'm sure, right. There'll probably be impacts on wider attitudes to AI and robotics. I, for a long time, thought that self-driving vehicles would be the canary in the coal mine that finally woke everybody up to what's happening. Because it's a remarkable fact that with AI galloping ahead, humanity's engaging in an extraordinary project, possibly ultimately to replace itself with a new entity. And 99.9% of the species isn't paying any attention whatsoever. Large language models came along and looked for a while like they might wake people up, but they haven't really.
Mm-hmm.
Maybe it will be self-driving cars, which are astonishing conceptually. You look at a car and there's nobody driving it. That's really got to be a wake-up call. What sort of impacts do you expect beyond transportation from what you're doing?
A couple of things. First, as it relates to the system that we're developing, this is one of the first embodiments of AI in the physical world. Large language models were stark to a lot of people because they felt so visceral. You can engage with this via text in a way you might engage with another human. Self-driving vehicles, I think, will be perceived similarly as a dramatic change to what folks are used to, but one I hope that people recognize they A, can trust, and B, benefit from. I think in trucking alone, that benefit is indirect, but it results in supply chains and ultimately prices that will be reflective of a much better situation than the alternative that preceded it. If you were to be watching Aurora's system and Aurora's trucks today, you probably wouldn't see much of a difference. In fact, you might not even notice when there's a human supervisor aboard and when there's not. And that's deliberate. We want these to be comfortable. We want them to operate in natural ways that I expect most just won't even notice. They will notice the truck looks a little different than others, but they've been driving around these things for 2 years now on the roads of Texas. And I expect that won't be quite so marked as it will be in robotaxi, where you're actually getting into the car that's operated by a self-driving system. I think we've seen compelling examples of how well that can go in what Waymo has done thus far in San Francisco. These are, by most accounts, remarkably normal experiences that folks are having in these cars. And they're learning, as we've always found for 15 years I've been doing this development, it typically takes a person a couple of minutes to get over the initial wonderment, surprise, and potentially fear to settle in and go back to their smartphone. It doesn't take long to get comfortable with it, certainly as a passenger or as a user, as you get familiar with it. And I think more and more, even those who just reside on the streets of San Francisco are getting more and more accustomed to seeing vehicles without a driver in them. I expect the same will be on the roads of Texas and on the roads across the Sun Belt and beyond as we expand our trucking product.
So pretty soon we'll just come to take them for granted, just like we're now taking large language models for granted, and the 99.9% of the species which isn't paying any attention to the rapid development of AI can go back to doing just that. Fair enough.
Yeah, I expect it will be less of an issue. Conceptually, it sounds like a big deal. And I think most people, when they hear, okay, an 80,000-pound truck is sharing the road with me and it doesn't have a driver in it, that sounds a little scary up front until you help them appreciate, no, it actually does have a driver. It's just a driver that's superhuman. It's a driver that sees everywhere all the time. It's a driver that pays attention to every angle, every other vehicle, every other pedestrian, whereas human truck drivers were looking at exactly one at any given time. It's a driver who doesn't get drowsy, doesn't get drunk, it doesn't get distracted. This recognition of what superhuman intelligence can do when applied to an embodied system like a truck or a car, specifically as it relates to performance relative to the status quo, I expect ultimately will lead humanity to a world where we would prefer not to have humans operating these systems.
Yeah, I can certainly imagine a world where the only place you'd be allowed as a human to get behind a wheel would be on a racetrack, and you'd have to sign lots and lots of papers saying that you disclaim all responsibility for your own welfare before you do so. Presumably you have metrics for what you regard as trucks having achieved prime time. Do you think of it as being, say, 25% of all the loads being carried across America? That's when you've made it, or is it 50%? And when do you expect to cross those sorts of barriers? Not you, but I mean the industry as a whole.
If I told you, I would almost certainly be off significantly. But what I will say is in the next few years, we expect to be in the thousands of unit volumes that we're operating on the road. To give you a sense for just how massive this industry is, I think annual truck sales in the United States are pushing 250,000. And the replacement rates are order 3 to 5 years for these fleets of trucks. And so there is remarkable opportunity. There's a lot of growth that's needed. Our expectation is that in the next several years, we'll expand across the Sun Belt and then move northward. In the next decade, I expect coverage across the whole of the U.S. highway interstate system with the self-driving trucks. And at that point, I think growth remains constrained by more operational factors than anything. But with two of the top three heavy truck manufacturers, one of the top global tier ones, and the top carriers in the world, all leaning into producing, supporting, and operating these assets across the country, I expect the volume will be quite large. Penetration will be significant, but I don't want to say 25%. I don't want to say 32%. We just don't know quite yet. But volume over the next few years will quickly enter the thousands and continue from there.
So that is an inspiring and positive vision. I wonder if I can tempt you to consider some of the implications of the technologies you've mentioned, because it seems to me that at least three of the technologies you've mentioned could have much wider implications. There are the sensors in your far-sighted LiDAR, for example.
Mm-hmm.
Then there's the verifiable AI, which might prevent large language models and similar from hallucinating and occasionally getting things wrong. But perhaps the most interesting is the virtual testing, whereby robotic systems, trucks and others, can test in simulated environments much, much more than is possible in the real world.
Mm-hmm.
It often used to be a joke. How do you escape from a Terminator robot? Well, you go upstairs. Why? Because the Terminator robot can't climb upstairs.
Can't climb stairs.
And there are lots of films of robots falling over. Well, that's no longer the case. And how? It's because they seem to be training themselves in virtual worlds, which are sufficiently representative of the real world. So do you see possibilities for these technologies to go further, and will Aurora be part of that?
I do see that potential. I'll say that right now we've got a lot of ocean to boil in the sectors that we've bit off. We need to chew what we've bit. There's a lot of work to do in trucking, a lot of work to do in ride hailing. But yes, ultimately, AI that can understand, predict, and safely navigate the physical world is opportune for a number of sectors. And that's not just for on-road. You've seen some of that crossover already. You've seen a few folks starting to talk about how the system that was developed or is being developed for vehicles on road ultimately has many of the capabilities they expect to need for something like a humanoid robotic type application. That's not our focus right now. And so we have zero product announcements to make in that regard or otherwise. But it is an area of crossover potential for a technology that understands, can sense, can predict, and can operate within the physical world. You mentioned a couple of other things on our virtual development engine. Yes, super opportune. And I expect valuable in a number of different environments, particularly those who are beset with similar challenges to the physical world, which is to say, huge combinatorial complexity, expensive empirical testing requirements. And then finally, you mentioned our first light LiDAR. This system we believe to be unique. Our IP portfolio surrounding it is quite strong, and the opportunity for it across a number of different sectors that have need of a sensor that has both long range, instantaneous Doppler, insensitivity to various sources of radiation or interference is really opportune. Again, not our focus at the moment, but there may come a day when the considerable portfolio of IP and technology we've developed, we can turn to other use cases, other applications.
Given that you're focused on trucking, you have the luxury of sitting back and watching the guys battle it out in robo-taxis and in passenger cars. There's an interesting debate going on about whether Waymo is actually the leader in self-driving because it has clocked up a lot more, way more miles, way more autonomous miles than any other self-driving car producer. But other people say that Tesla is actually ahead because every Tesla car is sending valuable data back to base. So although it's driven no truly autonomous miles, it's got orders of magnitude more data than Waymo has. Do you and Chris, who were sort of respectively running each of those companies before, do you have a view about which one is actually ahead?
We were running the self-driving portions of those companies, just to be clear. But yeah, as it relates to different approaches that are being taken, I'll say a couple of things and then I'll claim my privileged position as a bystander who gets to watch as this plays out between the two of them before I enter and take over. As it relates to the Waymo approach, Tesla approach, what I'll mention for volumes of data and their implication, we found that quality of data trumps quantity in these applications. And quantity itself is not quite what you might imagine for massive commercial fleets where you have to decide what you're going to send back. You obviously can't ingest all of that. You do have more, but your ability to process, manage, and productively train on or use all of that data, a lot of it just falls on the floor and is not particularly useful. This is where I'll highlight again a heavy virtual testing environment, which we developed at Aurora, allows one to much more deliberately craft that world that you want to expose the system to ensure that it operates safely in the various environments you care about. So quality trumps quantity. I think at the end of the day, quantity does matter, particularly if you're going to go for a brute force end-to-end learned system, as has been mentioned by one of those players they want to do. I'll say that our experience with end-to-end learned systems is that it's something of a fool's errand. It is a risky endeavor. It is one that lends itself to a challenge of introspectability and a challenge of actually addressing known issues. And what I'll say about that is we at Aurora had an internal experiment years ago where we actually tried this. And in developing that, what we found predictably was very, very difficult to know how it's going to fail a priori. And not being able to predict how a safety critical system fails is a problem. It'll be a problem for regulators. It'll be a problem for the motoring public. But it was also very difficult to train. When you encounter failures, if you survive that event as a company, which is a question in and of itself, addressing the failure, you have very few techniques available to you. When operating an end-to-end monolith, you're heavily constrained in what you can do to fix known issues. And the reason for that is because you have no ability practically to go in and tune specific elements of the system. All you can do is train it, and with more data, showing it more examples of the specific thing you want it not to do, and then cross your fingers and pray and hope that the training you've just done for it will result in it not failing in the ways that you've just seen it fail. And beyond that, hope against hope that it hasn't just introduced regressions in a number of other scenarios that might have been tangential to or similar to those circumstances, where what you just showed it will now cause it to do exactly the wrong thing in other ways. The unpredictability and the challenge of being able to actually verify that system is safe is, I expect, the linchpin in what will ultimately scuttle programs that seek a brute force end-to-end kind of monolithic AI.
Last question from me, Sterling. We've been talking about the US entirely so far, which is obviously where you're focused. I'm sure you keep an eye on what's going on elsewhere. China has a lot of self-driving cars running around, Europe not so much. Do you expect that once you've got your technology up and running, and let's say it gets to 25% of the loads traveling around the US, that the technology would be adopted and spread around the world very quickly? Or do you think that some countries, some regions will lag far behind?
It'll depend on what regulators decide to do. I think historically, Europe in particular has been a little more restrictive. The other type of approval that they've implemented versus US, where it's much more based on self-certification and federal motor vehicle safety standards. We'll see how Europe responds to what's happening in the US. I think the sequence that we are approaching this is right, in as much as the US as a regulatory regime allows for and appreciates the need for less prescriptive regulations to allow for flourishing of technology. As this develops, as it proves itself out, as our roadways become safer because of these trucks and cars, I expect it'll become incrementally easier for Europe to get over its historical reticence to allow things that are different from what it's allowed before. So yeah, we expect that ultimately we will deploy around the world. Deploying in China, or frankly, Chinese players deploying in the United States, is not likely in the foreseeable future.
Yeah.
Because tensions between these countries and various limitations that each has placed on self-driving as a technology of national interest. But elsewhere in the world, be that Europe, be that South America, we expect to deploy.
Well, as it's often said, we humans kill 1.3 million other humans with vehicles at the moment each year, and it would be a really good idea to stop that.
Yes.
And so we're very excited to see your progress and looking forward to seeing it in real life as soon as possible.
Thanks.
So what I've heard is bone deep, hard-won industry knowledge, technology knowledge. I've seen an inspiring vision, but most of all, I've seen a commendable focus, and I think that focus is going to stand you well in the months and years ahead. So I look forward to keeping an eye on your progress and celebrating it.
Thanks.
So Sterling, thank you very much indeed for joining us on the London Futurist podcast.
Thanks to you guys. Really good to be with you.